Welcome to the final module of the Intro to Coding course. You've made it, and now it's time to put everything you've learned into action by creating your very own Python app. In this module, you'll build a simple text-based quiz app. It will ask multiple choice questions, collect and evaluate answers, and give feedback and show a final score. Now, why this project? Well, this app pulls together everything you've learned: variables, loops, conditionals, lists, dictionaries, user input, and functions. It is all happening right here. Planning the app. The first part of planning our app will be our data structure decisions. We have to think about how we are going to store our questions. Now, what are our options? First, let's think about how to store our quiz questions. We have several approaches. The first approach will be using something like a list. Let's look at this code snippet for example. Here, our first option utilizes the list data structure. We have three different lists here for one specific question. The first list is named questions, where we have all the different types of questions we might have. As you can see, we have what keyword start the function, which symbol is used for comments, etc., etc. This could just be one question as it is. Because as we see here, we also have two different options. We have options A and B, where options A have functions as well as maybe a symbol here. Options B, we have DEF for defining, as well with a hashtag. We're answering two different questions here with one question. But notice that just for this one big question, we need three different lists to just display what we want. Now, this isn't very efficient and can get very messy very fast, especially once we start building quizzes that might have 10 to even 50 questions. That's going to be a lot of line of code. Imagine if every single question had one question list and 4 different options to choose. And if we had 50 different questions, that's a lot of code. So maybe this is not the best way to do this. Well, what if we look at using dictionaries instead? Let's look at this different approach. Here we have question 1, and question 1 is being created out of a dictionary. This dictionary has 3 key value pairs. The first key is question, with the value being the actual question itself. What keyword starts a function? Our next key value pair could be options, where we show the optional answers to the question. We can have the first value within here in our list, A, the next one could be B, and the next one could be C. We combine list in here to hold all the different options specifically for this one question. And finally, our last key value pair is answer, where the value being the correct answer to the question. Now, this is definitely a much better approach, right? So why dictionaries? Well, as you can see here, they let us group related data together. Each question has 3 pieces: the question text, the answer choices, and the correct answer. Dictionaries keep these organized, unlike lists, which can be a lot more complex to use. If we had a list of all these different options, we would have to essentially iterate through every single option within our list for every single question and their answers, which can become very tedious and can take a lot of time for your code. But here, let's look at our last and final option, and what I believe to be the best of both worlds is combining both lists and dictionaries all together to create a nested data structure. We can combine this by having one big list called questions that has a list of every single dictionary for every individual question. And this dictionaries, they will all have their all corresponding question, options, and answer. This gives us the best of both worlds because we can organize our data and we can have the ability to loop through multiple questions if we wanted to. We can do it in order, or we can even randomize it. Planning the app. Now, let's talk about program flow logic. First and foremost, we're going to want to map out our decision points. The first thing that we might want to take into consideration is using input validation. So we probably want something like this, where we're going to check if the answer that's given to us by our user is in the choices provided to us in our question. If we only have three options like A, B, or C, there's absolutely no reason why the user should be given to something like H, since it's not a proper choice. After receiving our input from our user, we also want to have some form of answer checking. We want to check if the user answer matches the correct answer. And if so, we need to be able to take that correct answer and tally up to our total score, as well as letting our user know that they got the question correct. Additionally, we also need to know what happens if they get it incorrect. Do we want to show the right answer? Do we deduct points? Do we give them a second try? And then finally, we also want to have some feedback. At the end of our program, we need to be able to take the score, compare it to the total questions, and let them know what was their score in total. Depending on what type of score they get, we want to either tell them either perfect score, we want to either give them a good job, or we want to fail them completely or just tell them to keep practicing. The next part will be talking about loops. What kind of loops will we want to use? Well, we're going to want a main quiz loop. This loop should take full responsibility of iterating through each question. We'll start it by something like this for question in questions, which allow us to go through every single dictionary within the list of questions. We can grab that question, ask the question, get user input, and check if it is correct. Throughout this entire process, we want to have another loop within here that can be input validation. So we can keep asking our user to choose an option within our question until we get something that's either A, B, C, or even D. We should not be able to take something like H or J that has not been prompted to the user. Now, what about variables? What kind of variables might we use throughout our program? Well, we might want something like score, so we can keep count of the integer to count correct answers. We're probably going to want something like user answer, which can be the string to store what the user typed. So whenever we ask the user for his input, this is the variable that's going to hold that. And then additionally, we might want to have another variable, something like total questions, which can be the integer for final percentage. These are some of the variables that you might see or have to use throughout your program. All right, well, what about functions? Well, for our functions, we might want to have one main function called run quiz. Run quiz could take in a list of the questions as input. It handles all the quiz logic and returns or prints the final score. So why a function? Well, it makes our code reusable and organized. Later, we could easily add features like play again by calling this function multiple times, or we can even use it to give multiple questions, multiple quizzes using other questions, right? We might want to have one quiz for history, one quiz for math, one for science. That way we can create different data structures for their own unique questions and then use this function that runs this quiz with those specific questions. Now, let's do a quick walkthrough of how our app should be broken down using some pseudocode. First and foremost, we're probably going to create a list of question dictionaries. Each dictionary has question text, options, and a correct answer. Next, we probably want to define the run quiz function. This function should set the score to 0. It should have some kind of for loop, like for each question in questions. It's going to allow us to iterate through our data structures. It should print the question and options. We should be able to get user input. We should have a while input is not A, B, C, or D while loop. That's going to prompt our user for an answer and to ask again for valid input if we don't get it. We should have an if statement where we say if the user input equals correct answer, I want to add 1 to score, and maybe additionally print out a message from our user like correct. Else, we print incorrect and show right answer. Now this part could be optional. If you would like to show the correct answer so that the student could study and learn from their mistakes, you can absolutely do that. Afterwards, we should be able to calculate percentage. And finally, print the final score and personalize message to our user, letting them know how they did. Then we can just call the run quiz function to start the app. Here, our pseudocode breaks down the complete logic and flow of how our app should work. This entire project uses every major concept from our course. We use lists to store multiple questions. We have dictionaries that organize each question's data. We have for loops that go through each question, while loops that validate user input. We have conditional statements like if, elif, and else that checks answers and give feedback. We're going to be creating variables to track and score our user input. We have functions that are going to organize our code. We're using user input to get answers from the player. And we might have string methods like .upper or .strip for input cleaning. After watching each video in this module, you're going to head to the coding space to complete the steps we reviewed. Think of these videos as your instructor-led roadmap. Your job is to bring it to life in code. Now, don't worry about getting everything perfect in the first try. Code is meant to be written, tested, and improved. So you want to start simple, get it working, and then make it better. Remember, before you start coding, you want to plan and always think through the data structure and logic first. You want better organization by separating your lists and your dictionaries. You want to break down complex problems with each feature being small and manageable so you can digest them easier as you engage your issues. Nothing here is completely new. We're just leveraging the tools that you have learned throughout the entire course. Start simple and improve gradually. Are you ready to build something real? Let's dive into how the quiz works in the next video. You'll see exactly how each piece of code works, and then it's your turn to make it happen.